6.3, which is the central limit theorem. All right. Now, after some feedback from you guys on my previous videos, depending on length and things like that, I'm going to jump right into some example problems. I put these page numbers right up here, this page 331 and 333. I'm going to briefly talk about how the changes are and the theorem behind it. But if you're looking for a reason why the theorem looks, please check out those pages. It does a nice job of explaining that. But after feedback, again, like I received last week, the amount of time on the videos was a little bit cumbersome, and the theory stuff, which is also very important, but some of you guys expressed that you would like just to dive into the example problems and get to those. So that's what I'm going to do, and I am going to reference some of the backing behind this theory, but as we go along. So the gist of it, how this is different from the last section that we did, which is the application of the normal distribution, is instead of talking about an individual person, how they compare to the population, we're going to talk about, like, let's say, a sample of the population and how the mean of the sample relates to the population. Right? So what you're going to see is, and I did number 10 here to reflect that difference, and I'll talk about that here in just a second. So if we look at the standard error of the mean, so instead of talking about just a one individual, we're talking about a sample of people from the population. For example, if we made a general idea or a statistic about the entire school, or let's say all seniors in the state of Iowa. We just did a study on those, and then we took our class, let's say 20 students, and we said, if we were to take that same data, let's say how we scored on the ACT. So if we took the average of our 20 students, how would we match up to the other population in the state? Okay, very general idea here. So let me talk about how that works. So the one adjustment that we have to make is the standard deviation we use in this case. We're still going to use the z-score, but instead of just using just regular standard deviation, we're going to incorporate the sample size that we're using. So in this case, the sample being compared to the population, we have the z-score is the mean of our sample minus the mean of the population divided by the standard deviation of the population divided by the square root of the number of people in the sample. Okay? And this just piggybacks right off of the other sections you've done. So there's real no difference from this thing. The only thing that really changes in this section, and some of you guys are like, oh, that's not too bad, is that all I'm doing is when I take the z-scores, I got to incorporate the number of people in the sample, which in this case we would mark as the square root of n. So let me show you guys how that relates to what we've been doing and the slight change that we're going to have to make. So the reason why I chose number 10, the teacher's salaries in Connecticut, was because it helps to identify what the big difference is. So you'll notice that on number 10 it says, what is the probability that a randomly selected teacher, and this is why I wanted to emphasize this. On your quiz, I'm going to ask you guys to read a problem and determine whether it's normal distribution or you would use the central limit theorem. And that's specifically based upon the fact, is the question asking about an individual, how they compare to the population, or is asking about a group of people? Okay, so let me, as a review real quick, I'm going to do 10A as a recommendation for you guys. If you pause the video and just see how you would do, that's an excellent way to get practice in this. So I'm going to dive right in. So because it's talking about an individual, I'm just going to use the general z-score that I used in 6.2, which is just take the value, the individual value minus the mean divided by standard deviation. Again, that's because it's just talking about an individual and how it compares to the population. And so we have, let's see, z equals, let's see, 52,000. I'm looking off my notes here. 52,000 minus 57,337 over the population standard deviation, which is 7,500. So that means the z-score equals negative 0.71. So I'm going to go to my beautiful chart here. Negative 0.71. So I'm going to go, let's see, that's a negative. So I got to go up here. So that would be right here. So 2389. And because it's asking for less than, that is my answer. So our answer is 0.2389. And that is exactly the same type of problem you would experience in 6.2. So 6.3, which we're studying now, is different because I'm asking about how a sample of people would match up against our population. So again, reiterating, sample of people. So, and the mean of that sample, how they would match up. So let's dive into B here real quick. And again, I encourage you guys to press pause if you need to. So I'm looking at 56,000 is the value. If the sample mean is 56,000, and then we have 57,337. Again, you'll notice that the population mean is the same. And then now this is where the new stuff has changed. We're going to use the population standard deviation, which is 7,500. But then I'm going to divide by the square root of my sample size, which in this case is 100. Okay? So, again, reiterating, this is the only thing that's changed from our section so far. Now the next step are just the same steps you took in 6.2 and the same steps you took in 6.1. So our z-score, if I type this in, would be negative 1.78. So if I go to my chart here, negative 1.78, scroll up a little bit here. Shoot. I just want to make sure I got that right. I always mess up that part. So that would be 0.0375. So 0.0375 would be, because it's less than, again, I don't have to worry about taking one minus it, or it's not between. I'm going to do one of these here in just a second. So my final answer is 0.0375. So what that is stating is the fact that if I took a sample of 100 teachers from the Connecticut teacher population, and I took the average of all of their salaries, those 100 teachers, the probability that sample would be less than 56,000, or the mean of the sample would be less than 56,000, is about 3.75% chance, or probability would be 0.04 if you round into the nearest percent. All right. All right, so let's dive into 18, which again, it's very similar to the last couple sections. In this case, though, we're going to be dealing with between. All right, so see if put the problem on pause for just a minute and see if you can come up with the answer to number 17. While I erase this real fast, you can definitely rewind to relook at those. And so let's dive into 17 real fast. Similar to what you would do in the last section is I'm going to find the z-score and the probability of these things in both cases. So like I'm doing two separate problems. So my first part is I'm going to do the 120. And because it's a lower one, I'm going to put it in red. So for 120, so I'm going to have 120 minus the population mean, which is 123, divided by 21, divided by the square root of 15. Again, a square root of 15 because I'm talking about a sample of 15 people. All right, and so that comes out to a decimal of negative 0.55. All right, and so if I go to my chart real fast, let me get to this, negative 0.55 would be, let's see, 0, 1, 2, 3, 4, 5, 29.12, or sorry, 0.2912, 0.2912. So the probability of that event occurring right there. Now, I'm going to do the next one in blue. So this would be, I need to find this part here, 26. So I got 126 minus 123 divided by 21 over the square root of 15, and that comes out to 0.55. It's just a coincidence in this case that they are the same decimal, both on the negative and positive side, and that's mostly because, do you see how far the distance is from 123? So you notice how they're trying to find, so this is 3 away from less than the mean, and this is 3 above the mean. So that's why they come out as nice numbers of 0.55. And so when I type this in a calculator, I got to find 0.55 on my chart. And some of you guys have used the digital one, which is completely fine. You get the same answer. So I get 0.7088. All right. So just like we did in the last section, or in 6.1 and we did in 6.2, is because we're finding between, we're going to take the higher probability and subtract this because we want to get rid of it. We want to find that middle ground. So that comes out to be 0.088 minus the 0.2912 equals, as my final answer, 0.4176. So put that into context. We're saying that if we took a random sample of 15 people and we found the mean within that group of 15 people, so what their averages were, that there is the probability of them having between 120 and 126 gallons would be a 0.41 or 0.42 probability. All right. Hopefully this video helped you out. Please keep those emails coming. Office hours are available. Please pay attention to those, and look forward to seeing you.